Okay, this is the first of 3 short videos on the topic of inverses for pre-calculus. And you can look in your notebook to figure out what notes number we're on, and then when we're in class we can compare and make sure we all agree on that. You can put the date and be sure to take good notes as you go through these videos. You'll notice that I've put gray boxes around the key points, and you should also take notes on the examples as you normally do in class. And I would like you to expect a short notes quiz next time we're in class as my way of checking to see that you did go through and learn from the videos. Okay, here we go. The first key point about inverses is that they have x and y coordinates switched. So, if your function f of x contains the point AB, then the inverse, which we would call f inverse of x, you see the little -1 symbol right here? It is not an exponent, it's just a symbol we're using to stand for inverse. And we use this symbol if it's a function. So the inverse would contain the point BA because the x and y coordinates were switched. And if you switch all the x and y coordinates, then the points that were in the domain of the original function f of x are now in the range of the inverse, and vice versa. The values that were in the range of the original function are now making up the domain of the inverse. So not only do the individual points switch, but the domain and the range also switch. Example number 1. We are asked to find the inverse of the function y equals 2/3 x plus 1. So because the domain and range switch, because x and y switch, our first step in this process is to actually switch the positions of x and y in the equation, and that would give us x equals 2/3 y plus 1. That's the inverse, but we don't typically leave it that way. What we do then is isolate y, or solve for y, however you'd like to say it. So in the process of solving for y, I'm going to subtract 1 from each side of the equation. Now the next thing I'm going to do is optional, but if you like having y on the left side, you can just rewrite your equation like so. And then I'm going to multiply both sides of the equation by 3/2 to undo the multiplying by 2/3. Okay, so this is the inverse of the original, and what I want you to notice is inverse operations are happening. So the original had a +1 in it, and the inverse has a -1 in it. The +1 was on the outside, the -1 is on the inside. The original had ×2, the inverse has divide by 2. The original had divide by 3, the inverse has multiply by 3. Those are inverses: add and subtract, multiply and divide. Of course, there are others. Now, if you want, you can keep simplifying this answer and distribute the 3/2, and we get the equation y equals 3/2 x minus 3/2. And that is the inverse, so that's our answer. And I thought we would graph both of these lines and see what their graphical relationship is. So we have y equals 2/3 x plus 1. So that has a y-intercept of 1 and then a slope of 2/3. So from that point up 2/3. We could go the other way down 2/3 and draw the line. And then the other one is the line y equals 3/2 x minus 3/2. So y-intercept at -3/2. And then from there up 3/2 or down 3/2. Graph that line. And what I'd like you to notice is that these lines look like reflections across the line y equals x. There's the line y equals x. Make that a little bit better. Well, that was worse. You get the idea though. And notice that the point of intersection of the two lines also falls on the line y equals x. So if inverses intersect, they don't always, but if they intersect, they will intersect along that reflection line. So key point number 2, inverses are reflections across y equals x. Let's do one more example. Example number 2. Find the inverse of f of x equals 2x cubed minus 6. So if you're looking at the steps I've written along the side, you'll notice that I added a couple steps. In example number 1, we had y equals something. This one says f of x equals something, and we're supposed to switch x and y. So why don't we just rename f of x and call it y? So step 0, rename f of x as y. So this is what we're going to take the inverse of. Step 1, switch x and y. Step 2, solve for or isolate y. So add 6 to both sides. If you like, rearrange so you have your y on the left. Divide both sides by 2. If you want, you can just write that as 1/2 x plus 3. And then to undo the cube, we're going to cube root. Remember, when you cube root, you don't need plus or minus. And then finally, I've added a step 3 as well, which is to rename the inverse. So instead of calling it y, I'm going to call it f inverse of x. Okay, so we have found the inverse. Now when we did example number 1 and we found the inverse, we looked back and saw inverse operations such as +1 minus 1, times 2 divided by 2. We can do something similar here, but what I'll do is I'll rewrite f of x a little bit. I'll factor out the 2. And now you see f of x has a minus 3, f inverse has a plus 3. F of x has x cubed, so cubing function. Inverse has cube root function. Those are inverses. F of x has times 2. F inverse has divided by 2. So we're seeing all the inverse operations in play in reverse order. Okay, next we're going to use a graphing calculator to verify that f of x and f inverse do look like reflections across y equals x. So what I've done is I've typed the original function into y equals, as well as the inverse function as y2. And you might be wondering where I found the cube root function. So what you're going to do is, once you're here in your y equals menu, you're going to press math, and then you'll see choice number 4 is cube root. And then you can type the rest of it inside that cube root. And then I'm also going to plot the graph of y equals x so that we can see the reflection line. And a typical standard window zoom 6, which takes us from -10 to 10, is a bit skewed. We don't see everything as proportional. So if you like, instead, you could try zoom square, zoom 5. It's a little more proportional. We see that line y equals x at a 45-degree angle. And we see our two functions do look like reflections across that line. So that's a good verification. Okay, that is the end of the first of 3 videos about inverses. So double check that you have all the important points in your notes and your examples, and you're ready for video number 2.